So for those of you at home, we are doing problem number 10 on the homework assignment. You might want to pause and look at it, but I showed them how to find the slant asymptote by dividing the denominator into the numerator. Then we set the denominator equal to 0 and solve to get the two vertical asymptotes. There's the two vertical. Up here is the slant asymptote. We went to the next page and we wrote them down right there. And we are going to graph these on here. So I go and get a graph, and we're going to graph these slant asymptotes on here. Y equals negative 1/4 x minus 1/4. So I'm going to go to the y-intercept, which is negative 1/4, about right here. And then from there, I'm going to go down 1 and to the right 4. That will be about right there. Down 1 to the right 1, 2, 3, 4. Or I can go up 1 and to the left 1, 2, 3, 4. Up 1, 1, 2, 3, 4. And so this is my slant asymptote. My vertical asymptotes we found on the other page were at x equals negative 2 and x equals 3. And then you guys are supposed to do what now at this point? Okay, find the x-intercept, y-intercept. How do we find the x-intercept? Top equal to 0. What is the top again? What's the numerator? See ya, Zach. Say that again. X cubed minus 16x. I can factor. Bye, Eli. Where are you going? Oh, that's all right. I forgot. See ya. Is anybody else leaving for sports today? Okay, see you, Kobe. Wrestling season's over. X equals 0. X squared minus 16 equals 0. What are these two x-intercepts? X squared minus 16 equals 0. 4 and negative 4, right? So there's those two and that one. There's 3 x-intercepts. So I'm going to mark them on the graph. There's a 1 at 0. That's 0, 0. That's also the y-intercept, so we don't even need to go find the y-intercept, right? 0, 0 is the y-intercept. 4 and negative 4. Those are all the x-intercepts. Now you put it in your calculator, right? And if you graphed it, it should look something like this. Right? Those get closer and closer to those asymptotes. This one right here, I believe, if everybody told me right in the last class, looks something like this. Crosses right here somewhere. And then this one over here goes like this. Whoops. It can cross horizontal and oblique asymptotes in the middle, but as you see, if it goes out to the right forever, the graph gets closer and closer to it without touching it. And as it goes to the left forever, it gets closer and closer to it without touching it. But it can cross a horizontal or oblique asymptote in the middle somewhere. But never will it cross a vertical asymptote because it's undefined at those points. So that's how you guys, just a review of how you do those kinds of problems. So let me review now that I have this microphone on so those people who aren't here can know this. Okay, we are going to go into logarithms today. And so we're going to totally be changing the subject. So we're going to have a quiz or a slight quiz or test next time. I'll review just a little bit before we take it. It will be on finding the domain in a context, rate of change, average rate of change, and graphing rational functions. Those are the 3 things that we'll be on. Okay, we'll have that short quiz. Today we're going to talk about logarithmic functions. Okay, I would suggest on this assignment that if you don't have a graphing calculator at home, you could use the graphing calculator online that's on my website. Or, yeah, you could download it from the App Store. Or you could just find all the asymptotes, x-intercepts, y-intercepts, have them graphed on there, and then come to class a few minutes early, punch those into your calculator real quick, and draw your graphs really quickly. That part shouldn't take very long. It's finding the asymptotes and the intercepts and everything that takes a little while. Okay? And also, just a reminder, and those people at home listening to this, that you need to bring Algebra 2 books for the next 2 weeks, the ones that we haven't even used all year, because we're going to be using them for the next couple of weeks, 2 to 3 weeks, to learn about logarithms, logarithmic functions, and so forth. Okay. Okay, I'd like everybody to take out your notebooks. Today, we're going to be taking a lot of notes and doing a lot of examples, mostly a lot of examples. I would like you to write down this objective right here that I have written over on the whiteboard. Today, we will learn to evaluate logarithmic expressions and solve logarithmic equations. One more time. Today, we will learn to evaluate logarithmic expressions, solve logarithmic equations. Those of you who are at home, you can't see that, so you'll have to just write it down. Logarithmic. I want you guys to know that logarithms are like one of my favorite subjects in math. I don't know why, but they are. So I like logarithms. So we're gonna learn about logarithms. I remember when I was in high school, learning about logarithms. I think my teacher spent one day talking about the definition of logarithms, and it didn't even take one day. It took about 5 minutes to talk about logarithms, and I didn't understand the definition of logarithm. I was lost on logarithms. It wasn't until I got to college that I even understood what a logarithm was. But they're really not that bad. This morning in my other class, everybody had it down by the time I left. Everybody, seriously. So yeah, even the stupid ones. So yeah, I don't have any stupid students. I don't have any stupid students. So. Huh? I have never had a stupid student. So. Okay. Raise your hand if you believe me. Huh? I probably have been. I think we all are at times, aren't we? Yeah. Okay, so, guys, today we're going to evaluate logarithms, but before we do that, I want to show you how we get a logarithmic function. It's important to understand a logarithm, you have to understand a logarithmic function too. You got to see a picture of it. At least I think you do. Okay, now y equals 2 to the x is what kind of function? Exponential, and this is it right here. This is what it looks like right here, right? We all know that. It has a horizontal asymptote along the x-axis. It passes through the point 0, 1, okay, and then it continues to grow exponentially really quickly, right, Tyson? It would cross at 3, 9. Because, wait, no, 2, it would cross at, you're right, because 2 to the third power would be 8, right? So it would cross at 2, at 3, 8. If you put 3 in for x, 2 to the third power is 8, right? So it would go through 3, 8. It would also go through 2 squared is 4, so it should go through 2, 1, 2, 3, 4. Hey, I wrote that pretty accurately, didn't I? So, okay. So what we're going to do is we're going to make a table of values for this exponential function. So we're going to start off with -4, then we're going to skip to -2, -1, 0, 1, 2, and 3. We're going to go that far. Okay, if I put -4 in here, what's 2 to the -4 power? 2 to the -4 power is equal to 1 over what? 1 over 2 to the 4th power. Remember, rules of exponents, if you have a negative exponent. And what is 2 to the 4th power? So it's 1/16, right? So we have 1/16 there. So what's 2 to the -2 power equal to? 1 over 2 to the 2nd, which is 1/4. So 1/4 power. What is 2 to the -1 power? 1/2, right? What is 2 to the 0 power? 1. Anything to the 0 power is 1. What's 2 to the 1 power? What's 2 to the 2nd power? What's 2 to the 3rd power? Okay, So that's what. Yeah. Anything of the form y equals a to the x power, or a is a real number. Anything to the 0 power is 1. So every exponential exponential equation is going to pass through 0, 1 unless you shift it left, right, or up or down, okay? It will always pass through 0, 1. Anything of that form, y equals a to the x. Okay, now what we're going to do is find an inverse of this. You guys, everybody write this down in your notes. The inverse of the exponential function is a logarithmic function.
Oh, so all we had to do was put 1 over...
No. Inverse is not a reciprocal. Okay, the inverse of an exponential function, yeah, the inverse of y equals a to the x. Do you want to write it down that way? Y equals a to the x, or an exponential function, is a logarithmic function, which would be written as y equals log base a of x. You know what? Instead of using a, I'm going to use b there, because in your book, they always use b. So we're going to write y equals b to the x, y equals log base b of x. Okay? By the way, that b right there is a subscript. Log base b. It's sub b of x. Okay? Log base b of x. It's a subscript. Okay, now, how do you find an inverse? Remember this lesson? How do you find an inverse? Swap x and y. That's right. So we're going to swap x and y. So we're going to take, and we are going to make a new function. This is for y equals log base b of x. And we are going to swap x and y. So what's my first set of coordinates? 1/16. -4. What's my next one? 1/4. -2. What's my next one? 1/2. -1. What's my next one? 1, 0. 2, 1. 4, 2. And 8, 3, right? And 8, 3. So we're going to plot those points right here, and we are going to get our new function right here. So we're going to plot 1/16 comma -4. Well, we go over 1/16. That's not very far. 1, 2, 3, 4. It's right by the line right there, right? Okay. What was that? Okay. 1/16 -4. 1/4 -2. So we're going to go to about right there. What's the next one? 1/2 comma -1. 1, 0. 2, 1. We're going to skip up to 4, 3. 1, 2, 3, 4, 1. Wait. 4, 2. Sorry. I was thinking that looked pretty off. And then 8, 3. So coming out to 8, 3. And so what we have is we have this function going up like this. Now notice, can this logarithmic function ever cross the y-axis? What's there keeping it from doing that? An exponent, right? I mean, not an exponent, an asymptote. There's an asymptote there. Why is there an asymptote there? Yeah. Well, do you guys remember in the exponential function right here that the range was greater than 0? All numbers where y is greater than 0 right here, because there's an asymptote along the x-axis right here. Well, when we switched everything, the domain became the range, and so now the asymptote is right there. Okay, which means that this number x, this domain right here, this is really important. Log base b of x always has to be a positive number. Yeah, so you can never get, and that's going to, when we start solving these equations at the end here of class, you'll see that we're going to get extraneous solutions, because if we get a negative number there, that solution is extraneous. Okay, now, as far as the graph of the function goes, the only reason I needed to show you that is so you can get an overall picture and we could see the domain of this function. It had to be a positive number. So what we're going to do now is we are going to learn, oh, let me just talk about this. Don't write these down. Let's just think about them. Okay, these are the characteristics of the logarithmic function. First of all, the function is continuous and it's one-to-one. What does it mean, continuous? There's no breaks. You can trace it without picking it up. What does it mean, one-to-one? Passes what two tests? Vertical and horizontal line tests. Just like the exponential function passes the horizontal line test, passes the vertical line test, and to have an inverse, it has to pass both tests, right? And so it does pass both first tests, and so the inverse is also a function. So it's one-to-one, which means that inverse is also a function. Okay, number two, the domain is the set of all positive real numbers. We can see by the graph, we just talked about it, that only exists to the right of the y-axis. Number three, the y-axis is an asymptote of the graph. That goes along with it. The y is an asymptote. And then number four, the range is the set of all real numbers. So this function goes down forever. And even though it's going to the right, it's going up forever. So the range can be as high as you want, go as low as you want. Okay, and the graph contains the point 1, 0. That is, the x-intercept is 1. Unless you do a vertical or horizontal shift, we're just talking about, though, the basic function. Just like the exponential goes through 0, 1, the logarithmic will go through 1, 0. Do we understand that? Okay. Now, that's enough of the graphs. We just had to kind of get an overall look at that. We'll come back to graphing logarithmic functions in a later section. What? Log is just an inverse of an exponential. The reason we have it is if you go back to the Bell work we did today, what was one of the problems? 3 to the x equals 243? Was that one of the problems you had? Whenever you have your exponent, your variable in the exponent, you can use logarithms to get the variable out of the exponent by making the inverse. And the logarithm is the inverse. And so that's why we have them, so we can get the exponent or the variable out of the exponent. Okay? Well, you don't put it in your calculator like that. You have to put it in logarithmic form. And that's what we're going to learn about next. We are going to learn about the definition of logarithm right here. I want you to write this down. Okay, we have if x equals b to the y, then y equals log base b of x. This is the most crucial part to understanding the lesson today. I'll show you. But you know what? Actually, the calculator part, we don't need to worry about today. You're not going to be using your calculator for what we're doing today. Today, you're just learning how to change back and forth. We'll be doing the calculator part on another day, and I'll show you. I promise. So you don't have to look. So you don't have to do what I did when I was in high school. Okay? Took a little bit longer. Okay. So the definition of logarithm: if x equals b to the y power, then y equals log base b of x. Notice in this one, this is called exponential form over here because we have an exponent. And what is the exponent over here? Y is the exponent. Notice when we change it to logarithmic form, is y now an exponent? It's not in the exponent, but guess what? It still is an exponent. But it's not written in as in exponential form. Y equals log base b of x is the new form. What we're going to learn today is how to switch from one to the other. You have to be able to switch one to the other. If you can get this down where you understand how to switch it from one to another, logarithms are easy. If you can understand this definition and get it down really well, which my goal today for you is to get it down really well. We're going to do several examples. Then you guys will have this down. I want you to write one more thing down. I want you to write down a logarithm is an exponent. Write that down. When I went to college and a professor told me that, all of a sudden started clicking for me. A logarithm is an exponent. And I'll show you why in a second. Colby. Oh, yeah. So yeah, this one right here, you're talking about 3 right here equals x. That's how you'd rewrite it. Yep. That's what we're going to be doing right now. We're going to be rewriting these. Right. Yeah, it's the exact opposite. Well, the exponential y goes up fast and x moves over slow. And then it's the other way around on the other. Right. Exactly. What I'd like you guys to do right now, before I tell you how to do this, I just want you guys to study these two expressions right here and see if you can use log base 8 of 1 equals 0 to rewrite this in your own, rewrite it from logarithmic form to exponential form. Okay? I want you guys in your groups, think about it first, see if you can do it. I'm going to give you a second. Okay, it looks like most of you have this. So how many of you got this? How many of you got that? Okay, good. Looks like you had it. This, I wanted you to make sense of it yourself first. This is how I think of it, if you want another frame of reference. I remember this. B is the base of this exponent y right over here, right? Since b is the base of y, b is also the base of the logarithm. It's the one we write as a subscript over here, log base b, right? Okay? And I told you, y is the exponent. Y is the exponent on this exponential part right here. So when you rewrite it, it's the part that's by itself. Okay? And then the x, you can see where the x goes. I let the x fall in where it does after that. I just remember the base of the exponent and the base of the logarithm are the same number. And the exponent of the exponential is equal to the number that's by itself on the logarithmic. Okay? Does 8 to the 0 equal 1? Yeah. Okay, now this next part I want you guys to do is a sage and scribe. So with your shoulder partner, if there's an odd number of people in your group, actually, yeah, you two work together. You go over and work with him. Will you go over and work over there real quick? We're gonna do a bunch of examples. I want everybody to have a shoulder partner or a face partner. Okay, are we ready? Okay, here we go. First one, I'm just going to give you 30 seconds on each one. I want you to do this as a sage and scribe. Everybody who's the closest to the front of the room is going to put down their pencils. And you're going to be the sage. Scribes, pick up your pencil. I want you to do it this way. You'll get it better if you have to explain it out loud. And everybody's going to get a chance to explain it out loud. Kai. Okay, wait till we get this one done. Okay, first one. Sages, go. Okay, here's the base, right? 4 is the base. Looks like most of you guys got it, but so it's going to be the base of the exponent. The exponent is a number by itself over here in this logarithm, right? And the 16 just falls in. Is 4 squared equal 16? True, right? So we're writing it from logarithmic form to exponential form. Okay, switch roles. Sage and scribe. Switch roles. This one right here. Go. All right. Logan, what did we get? 2 to the negative 1/4 equals 1/16. Is that a true statement, you guys? Yeah, remember 2 to the negative 4th can be written as 1 over 2 to the 4th, which is 1/16. Okay? 2 to the negative 1/4 is not going to be 1/16. 2 to the 1/4? 2 to the 1/4 power, that's going to equal a small number. Okay? 2 to the negative 4 is 1/16, not 2 to the negative 1/4. See, 2 to the negative 4 can be written as 1 over 2 to the 4th, right? And 2 to the 4th is 16. Okay, switch roles again. Here we go. Okay, Michaela, what'd you guys get? Say that again. Okay, 1 over 27 equals 3 to the negative 3. One more time, you guys. The base of the logarithm is the base of the exponent. The number by itself is the exponent, right? And then the other number goes by itself on that side. 127. Good. One more time, switch. Okay, this time we are given exponential, and you have to write in logarithmic. So switch over, Sage and Scribe. Just do it with your group. Let everybody have a chance to think, Colby. Okay, do it on your own. Stephanie, what did we get? Okay, I want everybody to say this. I want you to know how to say it. Okay? It's that you say log base 10 of 1,000 equals 3. Say it about 3 or 4 times to yourself. Okay, next problem. Change this to logarithmic form. Okay, Stetson, what did you guys get? Okay, log base 9 of 3 equals 1/2. I think you guys got that down. Okay. Everybody say this one. What is it? Log base 4 of 64 equals 3, right? Okay, now, you guys, now we're going to evaluate. You guys got to figure out what y is. I'm going to give you a minute on this one, see if you guys can figure out in your group, with your shoulder partner, see if you can figure out what the value of y is. Without using a calculator, you don't need one. Sarah, what's the answer? Audrey, what's the answer? Sarah, what's the answer? 6. Okay, how many of you changed it to exponential form to get it? Good. So 2 to the y power equals 64. So you're asking 2 to what power is 64, right? Then you can use the same method we did for the bell work problem. You can just guess and check, put numbers in. You can start with, 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16. 2 to the 5th is 32. 2 to the 6th is 64. So y equals 6. How did I get what?
How did you get that? Because
No, the base raised to this number. That's the exponent. And that's what it's equal to, right? Okay, so that's the same as we've been doing all along. Okay. Now, you guys, this time notice I don't put a variable here. It's just log base 3 of 81. What am I asking right here? Can I raise a hand? Who would like to say? Okay, wait. Not what the answer is, but what is it asking? Like this one was asking 2 to what power is 64, right? This is what it's asking. 2 to what power is 64? So if I erase this y over here, 2 to what power is 64? That's what a logarithm is asking. 2 to what power is 64? It's asking for the exponent. That's why we say a logarithm is an exponent. So if we go to the next problem right here, what is this one asking? 3 to what power is 81? Right? 3 to what power is 81? What's the answer? Yeah, 3 to the 4th power. Now, if you wanted to put an x on the end right here, or y, and go 3 to x equals 81, because that's what it's asking. 3 to what power is 81? Okay? And the answer is x equals 4. Okay, switch, Sage and Scribe, whoever went and did last one, switch over and do this one. Okay, what'd you guys get for the answer? 4. Because 4 to the 4th power. 4 to the 4th power equals 256, right? This was asking 4 to what power is 256? Okay, now, we are going to use what we learned how to do to solve equations. I'd like you to write this in your notes. Use the definition of logarithms to solve simple logarithmic equations. And write this one down, because this will be your note. In your notes, this will be your reference to learn how to solve these equations. We're going to start off with simple equations, and we'll work our way to more difficult ones in other lessons. But today's equations are all going to be pretty simple. And I think you guys could do this one by yourself. I'm going to give you guys about a minute to see if you can solve this. And how many of you guys got it solved already? Okay, a couple of you. The rest of you guys, I want you guys to solve this one. You might want to change it to what form? Exponential, and go from there. Okay. So if I change this, Tyson, if I change this to logarithmic or to exponential form, what would it say?
4 to the 2.5 power.
Now, you guys, I know that most of you probably at this point put 4 to the 5/2 into your calculator, okay, or 4 to the 2.5 in your calculator, which is fine. But I need you to learn a little technique, because this will help you in solving some others later on. I need you to do something like this. We can rewrite 4 as 2 squared, right? And so that gives us 2 squared to the 5/2 power. Now, when you have a power to a power, you multiply. Do you remember that? So we're going to multiply 2 times 5/2. So what happens when you multiply 2 times 5/2? You just get 5. So this becomes 2 to the 5th power, because the 2's cancel out, equals n. And 2 to the 5th power is 32, right? Now, I know most of you guys use your calculator, and that's fine. I just need you to know this technique, because you're going to need it later on when we start solving some other equations, when you have variables and you can't use your calculator. So you need to know that technique. Okay, try this one using that technique. I want you to do Sage and Scribe on this one. Okay, so whoever you're on, switch over and tell the other person how to do it. So 9 to the 3/2 equals x. If you wrote it in exponential form, what does 9 change to? 3 to the 2nd. 2's cancel out, and you have 3 to the 3rd equals x. And what's 3 to the 3rd? 27, right? 3 to the 3rd equals 27. How many of you had that? Good job. All right. You guys got this down. Okay? One more of those. Okay. Give you a second on that one. Okay, what'd you guys get? 1024 is the answer. 16 to the 5/2 power equals x. By the way, there's 2 ways you can reduce this down. Most of you guys probably did this. Crossed out those, and you went 4 to the 5th power is 1024, right? You could have also done this. You could have written 16 as 2 to the 4th power. And 4 times 5 is, oh, that's 5/2. 2 will go into 4 twice, so you get 2 to the 10th power. 2 to the 10th power should be 1024, is that right? Anybody check it? So there's another way to do it. Okay, so you can break that one down either way. All right, now, before I do this one with you, I need to show you a little trick right here. Okay, let's say I had 3 to the 4th power equals 3 to the x power. Raise your hand when you know the answer to that. Don't say it out loud, please. What is x? Just raise your hand. Okay. This is not a trick question. Okay? The answer is 4, because if you have a number raised to the 4th power, and you have this equal sign saying these 2 things are equal, okay? And the same number on the base, it's got to be the same number on the top, or it's not going to be equal, right? Yeah. Let me ask you this. Raise your hand when you know the answer to that one. It's always someone that can't help themselves. This is not a trick question. It's pretty straightforward. What's the answer, you guys? 4. Because if I have log base 2 on both sides and this thing's equal, that x and that 4 has to be equal, right? Okay. So now that you know this, okay, now that you understand this, see if you can solve that problem. Colby says the answer is 2. Is that what you said, Colby? Root 2? Colby says the answer is root 2. Square root of 2. Anybody agree or disagree? Okay, Talon, what do you think it is? Talon thinks it's 2. Anybody else? Yeah. Okay. You guys, there's actually 2 answers, but one of them is extraneous. Does anybody know the extraneous one? Huh? It is -1. How do you know that? Okay. Hey, you guys. This, these are both log base 5, isn't the p squared minus 2 equal to p? Right? Same idea as what I just showed you. So this is what kind of equation right here? Oh, whoops, I wrote that wrong. That's supposed to be p squared minus 2, right? What kind of equation is that? Quadratic. How do you solve a quadratic? Well, it starts off by setting it equal to 0, right? What does that factor to be? That's what it factors to be, right? 1 times -2 is -2. 1 plus -2 is -1, which is the middle term. And so the answer is 2 and -1, right? Well, there had been something on the other side, so it depends on what the other thing is.
What if it was log 5, 0?
Log base 5 of 0?
Log base 5 of p squared.
It has to be that number right there. Remember when we graphed the logarithmic function? Whatever number is right here has to be greater than 0. It can't be negative. It can't be 0. It has to be a positive number.
So it has to be square root of 2.
No. I mean, it possibly could be. There's some.
Because square root of 2 makes that 0.
Yeah. Yeah. No, it couldn't have been. Okay. So anyway, one of these is extraneous. Which one?
The negative one.
Yeah.
Be negative.
Remember, if I put -1 in for this p right here, this number has to be greater than 0. So -1 is extraneous. 2 is the only number that works. Okay, everybody, solve this one. When you have it as a group, everybody in your group understands it, raise your hand. Wait, yeah. So that answer was 5. I forgot to turn it on, so I had to do that for people at home. Quadratic equation, -3 was extraneous. Okay. Reminder, this is out of the Algebra 2 book. So you got to dig out your Algebra 2 books, dust them off. Okay, page 515. By the way, these problems I gave you, the evens, you know all those problems where you had to change the logarithmic to exponential or exponential logarithm or evaluate? Pretty easy. You can get those done in 5 minutes, which you have about 4 minutes left in class, so you got time. All of them, 44 through 49, are solving equations, the easy kind. 56 and 57 are solving equations. 65 and 66 are practical problems. They have to do with the Richter scale, because in the Richter scale you use logarithms. Also in finance you use logarithms, if you ever work with compound interest formulas. So anyway, there's some ideas on where you can use this. Okay, this assignment is due in 2 class periods. Okay, so we're going to take, remember, we're going to take the test next time. /quiz. I'll review a few minutes before we do that. It will be on domain in a context, graphing rational functions, and average rate of change. All right, see you guys.